Okay, so we have an arch on a bridge. So we've all seen bridges across rivers, and often an arch. And we've got the height of that. It's represented by this equation. So the h is the height in meters. This will be h, which we're going to use as y, and x, and that's above the water, right? So the water is somewhere down here, right? And this is the bed of the road or whatever, and there's the arch of the bridge. And determine the distance between the bases of the arch. So we can graph this. So when we're solving, this is solving problems, right? We're going to solve graphically, we're going to solve by factoring if we can, we're going to solve by using quadratic formula if we can't factor, and we're asked to algebraically determine. Okay, so this one, let's turn that on. We'll go to y equals, punch in the equation, negative 0.005061 x squared plus 0.49915 x. And we hit graph. So it almost looks like a straight line, right? But we know we really should be starting at 0, right? Because we want to get the distance from here. And this should be a quadratic. It looks linear. So we can go into the table and just kind of get an idea of when's this going to come back to 0, right? So there's various heights. You can see it's climbing up. And it's kind of still climbing 10 or 50. So, okay, I don't know. Let's go from 0 to like 50 by 5s. And the height can start at 0, and I don't know where it's going to max out. Let's say 25, again by 5s. We're going to play with this. All right, so 50 actually kind of looks about halfway, right? But now it's starting to look like a quadratic. So let's increase that to 100. Maybe go by 10s. By 10s, graph. Okay, and we're good, right? We can see that it's going to come back there. So the distance between the bases is this distance here, which is just the x-intercepts, right? And we know that one of them is 0, right? So you put a 0 in for x, you're going to get 0. There's no constant here, right? So, or 0 is the constant. So we want to find this guy. So second calc, and we can do zeros this time. So left bound, I need to, will be above. So I just need the y value to be positive. Okay, that's positive. Right bound, I need the y value to go negative, right? Because I have to go through the 0. And then to guess, and we get 98.6, right? So this is 0, 98.6. Rounded to the nearest tenth, and determine the maximum height of the arch. So maximum height, second count maximum, number 4. Left bound, going to back our way up to here. Enter, and it shows you where when you've got your boundaries, right? Right bound, enter, and my guess, somewhere in between. And 49.3 and 12.3. Now, 49.3 shouldn't be a surprise, right? Because we got 0 to 98.6. Half of 98.6 is 49.3. That's where the vertex is going to be, right? Axis of symmetry. So x equals 49.3, and then the y. Okay, so what have we got? We have a distance of 98.6, what are we in, meters? Between the bases of the arch. and a maximum height of 12.3 meters. Okay, so again, something that can be solved graphically using quadratics. Little shout out to the last unit, right, which is finding the maximum. So still need that skill. I'll pause and let you. Determine 3 consecutive odd integers if the square of the largest integer is 33 less than the sum of the squares of the 2 smaller integers. This is what we call a number problem. 3 consecutive odd integers. Okay, give me 3 consecutive odd integers. 1, 3, 5. Give me another 3 consecutive odd integers. 7, 9, 11. Okay, so let the integers be x. Now what's the next odd integer? First one's x, the next one is? How do you go 7, 9, 11? X is 7. What do you do to get 9? Plus 2. What do you do to get the next one? Plus 4, right? So just think of 3 out, 1, 3, 5. If that's a 1, 1 plus 2 is 3. 1 plus, I'm going to have to add 4 to get 5, right? If that's 7, this will be 9, this will be 11. Okay, good, so I've got 3, right? Like make sure, because if you get this wrong, the whole thing falls apart from there, right? You can't actually solve it, and so we know when we do this, we know that it has to factor, right? If we can get a quadratic, because we know they're integers, right? The numbers 5, 7, 9. Okay, so this should factor. We should be able to solve by factoring. Okay, if the square of the largest integer is 33 less than the sum of the squares. So which one's the largest integer? Okay, so that's the square of the largest integer. And it's 33 less. So what are we going to do to get 33 less? So is 33 less than what? The sum of the squares of the 2 smaller ones, right? So that should be x squared plus okay, alternatively, right, we could have squared this and then added 33 to the other side, right? 33 less than. Okay, so does that seem to match up with the words there? So the square of the largest integer is 33 less than. Oh, so no, I don't want to subtract 33, do I? I want to add 33. Because it's 33 smaller than the sums of the other 2, right? So I don't want to make it smaller. It's already smaller. I'm going to have to add 33. So you always want to check that, right? Doing word problems. Not like, the whole test is not word problems. There will be a couple on there, right? 2 or 3. Make sure things match up, right? Make sure that if you're reducing a ticket price or whatever, that you try different numbers in there. You say, yeah, okay, that makes sense, right? I'll go from 10 to 9 to 8 to $7, and I'll do this, that, and the other. So if this square is less than these guys, then I have to add to it to make it equal, right? It's smaller, and I gotta add more onto it to make it equal. Okay, so now we just square. X squared plus 8x plus 16 plus 33 is x squared plus 4x plus 4. Okay, so we're into the expansion stage now. So we expand it out, we collect all the terms together on each side, and then we move everything to one side to get a quadratic equation, right? What's characteristic? It's got to be equal to 0. Okay, so we get x squared plus 8x plus 49, and we've got 2x squared plus 4x plus 4. drag that down. No, it's not going to move it. Let's put that back up. Okay, hang on. Just move the frame. Okay, back in position. Okay, so let's subtract x squared from both sides. So 2x squared minus x squared is x squared. We've got, we can subtract 8x. 4x minus 8x is minus 4x. Subtract 49 gives me minus 45. Okay, and that makes one side, now one side is 0, the other side is this. So we might as well just write equals 0. You know, even though what I really did was move this over, so I really have 0 equals this, but, you know, switch sides. Okay, this should factor, right? It has to factor, but as a solution, so if you're going to solve this and it doesn't factor, then you know you made a mistake. Two numbers that multiply to 45 and differ by 4. 5 and 9, right? Okay, so which one's the minus? 9. Speaking of German for a moment. 9. Switching back to English, right? The larger number is the negative one, right? Because I need to get a minus 4x. Okay, because you would have found out, because once you factor, what do? Check it, right? Because, you know, the numbers, you're going to get the numbers right, 9 and 5, probably. I mean, you get 3 and 15, you're just going to get nowhere near 4. So, right, I mean, if you drop 3 and 15, how do you combine 3 and 15? You can get 18 or you can get 12, right? I mean, I can add, and I can get negative 18 and negative 12, but that's the only numbers I can get out of 3 and 15. Out of 5 and 9, I can get 14, or I can get 4. Okay. So what do we got? X squared plus 5x minus 9x is minus 4x minus 45. Okay, it's all good. So x equals 9, or x equals what? Negative 5. Now, did it say positive integers or just integers? So it just said integers, right? Okay. So then the three numbers are 9, 11, and 13, right? So we're starting now, that's x, right? And we got x plus 2, and then x plus 4 for just 9, 11, 13. And, or, negative 5, what comes next? Negative 5, where are we going? Negative 3, right? We're not going down. Negative 3 and negative 1. Okay, so I'm going to pause that, not that way. Okay, and then the look back, it's just for the game film, right? So the look back is just, you square the number, 13 squares 169, you square these two guys, add them together, you get 202. 169 is 33 less than 202, and the same for that. And do it by going back to the words at the beginning in case you set this up wrong, right? Like if we had done the minus 33 here, we'd have a different setup. Okay, number 3. At noon, a sailboat leaves a harbor on Vancouver Island and travels due west at 10 kilometers per hour. 3 hours later, another sailboat leaves the same harbor and travels due south at 15 kilometers an hour. At what time to the nearest minute will the sailboats be 40 kilometers apart? Okay, so I want to know north, east, south, west. So I want to have an idea here. I can draw a little diagram. So I've got one sailing west at 10 kilometers per hour. So we'll say let x be the speed. No, we've got the speed. Let x be the amount of time. Since noon. So this guy is going to be going 10x kilometers, right? In a time of x. So at noon, it's gone 0. In 1 hour, it will have gone 10. In 2 hours, 20. In 3 hours, 30. And this guy is going down here, but it's 15 times x minus 3. right? Because things don't really start till 3 hours. I mean, we could put in a time of 1 and say, yeah, this guy's at negative whatever, but really in this, our x value is really going to start at 3. Okay, we could start it at 0 if we're graphing it or that, but in reality, the time really starts at 3 hours when the second one leaves and it starts traveling. And we want to know when this distance here is 40. So if we look at it, we have a right triangle, right? We've got 10x squared, we've got 15 times x minus 3 squared, that whole thing squared, right? And 40 squared. So we could set this up as Pythagorean theorem. So this is the distance the first boat has traveled, well, the square of that. This is the distance the second boat has traveled, and we square that. And then this is the distance we want them to be apart, which is 40, and we square that. So let's kind of just expand this and make this 15x minus 45. So it's easier to expand this first and then square it than it is to kind of try and square that. You might less chance of making a mistake this way. All right, what's 10x quantity squared? 100x squared. Now we got to use FOIL on this, right? So it's first, well, or you know how to square a binomial, right? It's this squared, it's this times this doubled, and then it's this squared. Right? That's the sort of quick way of doing that. Or just FOIL it out. Let's go here. 15x minus 45. Okay, so 15x times 15x is 225x squared. 15 times 45 is 675. Do that on actual. Okay, yeah? Minus 675x, 45 times 15, minus another 675x. That's where the double comes from, right? You take this times this and double it. Because you're getting it once as the outer and once as the inner. And then plus 2025. Okay, so we can now transfer that over here. We've got 225x squared. Double 675 is what, 1350, so minus 1350x plus 2025 equals 40 squared, which is 1600. So we're gonna collect these guys together, move the 1600 over, so we get 325x squared minus 1350x plus, and it's 2025 minus 1600, right? So it'll be plus 425 equals 0. Now we could, I mean, I think 25 is probably going to go into all of those, right? So what's 325 divided by 25? That's right, 12, 13. So we got 13x squared. 1350 divided by 25, 54. 425 divided by 25, 17. Okay. So numbers are a little bit easier, right? As far as we can go, because 13 and 17 are prime, so we can't divide anything else out. I don't feel like factoring that. I don't know if it does factor. Probably doesn't. So we're just going to use quadratic formula, right? And you can do that. Anytime it asks you to algebraically determine, if it doesn't specifically say by factoring, or, I mean, the other one, we knew it would factor because we knew that we had to get integers, right? So it has to factor. You got to get like x plus 9 or x minus 9. It has to be integers, so it should factor. So you might want to spend a couple of minutes more trying to factor it than you might on something like this, where you go, I don't know. Just going to do it algebraically. So a equals 13. B is negative 54. C is 17. Formula. X is equal to negative B plus or minus square root of B squared minus 4AC all over 2A. Substitution. Negative negative 54 is 54. Plus or minus, a little bit too big. Negative 54 in brackets squared, right? So you know by now, if you've done any quadratic formula stuff, you know this has to be a positive when you square it, right? Well, even if that's a negative to begin with, it'll be a positive. Minus 4 times 13 times 17. Clean that up. 13 and 17. So if you write something like that, extend your radical sign out above, right? Don't leave this stuff just sort of hanging out there, right? It's part of the root, and then, you know, the fraction bar has to go under the whole thing, and that's 2 times 13. Yeah. Yeah, it's minus 54 though, right? It's negative b. So negative negative 54 is 54. Okay. All right. What's this work out to? So I'm just looking, man. It might be a little quicker. So I'm just curious, what does the number under the radical sign work out to? And it works out to 2032, and the square root of that is 45. Okay, which means we're going to get a couple of answers here, right? But one of them will be less than 3 hours. We should work it out, and then we'll say, yeah, but that doesn't work, right? We can't use that in our context. Okay, so let's do this. So I'm going to do, what am I going to do? Okay, I'm going to go 54 plus, because this is our actual answer, the square root of, so I'm going to work this out first, then I'll divide by 26, right? Because otherwise I have to put brackets around the whole 54 plus. So I'm just going to do this. 54 plus, I'm not going to put negative 54, right? It's 54 squared. Negative 54 squared is the same as 54 squared. Okay? Minus 4 times 13 times 17, right? So that's the top. 54 plus the root of whatever. Enter. So it's 99, right? And then what are we going to divide that by? 26. Okay, 3.81. So let's write x equals 3.81. What's the other answer? Well, let's go back to this. So second function, enter. Do that twice. Go back to this. We need 54 minus this. Put in a minus sign. Divided by 26. Right, x 0.34. Right, now we know, you know, and here, let's put a little, since x must be greater than 3 hours. Okay, so the solution is 3.81 hours, right, after 3.81 hours. So the votes, let's go back up here. What time to the nearest minute? Ooh, okay. So we have 3.81 hours. So how do I change decimal hours into minutes? What do I have to do? So if I had half an hour, how many minutes is that? 30. So how do you get that? 0.5 hours, how do I get 30 minutes? 0.5 times 60. 0.25 hours is? Quarter of an hour? 15 minutes, right? So 0.25 times 60. Okay, so what are we going to do? We're going to take 0.81. We know we got 3 hours, so 0.81 times 60 is, what's that work out to? 48.6. So that's 48.6 minutes. Okay, so it takes 3 hours, 49 minutes, rounding to the nearest minute, for the boats to be 40 kilometers apart. Okay. So, always some little twist here. In this case, changing decimal hours. Generally in time, the only time we use decimals is when we're doing parts of a second, right? Say like 3.2 seconds or whatever. You don't say 3.2 minutes. You say 3 minutes and 12 seconds. Okay. Now you could say 3.5 minutes because everybody knows what that is. 3.25 minutes or 3.25 hours. The sum of the squares of two consecutive odd integers is 394. Algebraically determine the two integers. Okay, so we need to. But, we should be able to do that algebraically anyways because we know it's going to have to factor. Okay, so let's do this. Let's be quick. And thin lines, too. Let the integers be what? X and two consecutive odd integers. X and X plus 2, right? Just think. And then when you write that down, then try it. Okay, 11 and 13. Yeah, okay, that works. 27 and 29. Okay, they're odd integers. The sum of the squares. I knew that was going to happen. It's just too thin of a line. Now at this point we should recognize that, hey, maybe we're going to get a set of positive numbers, like 9 and 11, and a set of negative numbers as well, because when I square a negative number, we get a positive value. So, okay, x squared plus 4x plus 4 is 394. 2x squared plus 4x minus 390 is equal to 0. Since it's equal to 0, we can divide everything by 2 because they're all even numbers. Gives us x squared plus 2x minus half of 390. I don't know, what, 119, 9, 195. Two numbers multiply 195 and differ by 2. Bless you. Okay, so if you want to start guessing numbers, if they're going to be really close together, then what's the square root of 195? Work out the square root of 195. 13. Okay, so we want to start with like 13, right? So what's 195 divided by 13? 15. That's our two numbers then, right? So here's the deal, right? When you know the numbers are close, go to the square root, because that's where, that's the same number, right? Square root, like 14 times 14 is 196. That's the same number. So if I want two numbers close, take the square root, start working your way out from there. Okay, so we've got x, and we got an x, and we got a plus and a minus, and I want to put a 13 and a 15. Who goes where? Which one's positive? 15, the bigger one, right? Because the bigger number here is positive. So the two numbers are okay, well, actually solved. So x is negative 15 or positive 13. So they're 13 and 15, or negative 15 and negative 13. Right? Which means we really only have to do one check. Right? 13 squared plus 15 squared, 394. Done.